Okay boys, so this is a video to introduce you to the sine rule, which is something we use in triangles and you need for your higher tier GCSE. So first of all, just a little bit of a reminder, you might remember SOCAN, which is trigonometry for right angled triangles, alright, specifically right angled triangles, and you can use this to find out missing lengths and missing angles. Some of you may not feel too confident that you remember SOCAN brilliantly, but it doesn't matter too much right now. I mean, it will matter for your exam, but it won't necessarily hold you back from being able to do the sine rule because the techniques are somewhat different. So the sine rule works for any triangle. It will work for non-right angled triangles, and actually it will also work for right angled triangles. And you know, you might actually use this when perhaps you should be using this sometimes. That's possible. Let's get straight into it. Let's show you what the sine rule is, and we'll show you some examples of how you can use it. Okay, so what I'm going to do is draw a random triangle. Okay, like this. Sorry for drawing in pen. And then we'll label the sides, the angles, capital A, B and C. And then the sides, this will be side little a, this will be side little b, and this will be side little c, because they're always opposite each other. Alright, little c is opposite big C, little a is opposite big A, little b is opposite big B. This is what the sine rule says. If you take the side A, and you divide it by the sine of its partner angle, so this side length divided by the sine of that angle, you will get the same number as if you took B and divided it by sine of B. And you'd get the same number if you took side C and you divided it by sine of angle C. Alright, and that's a rule that will work in any triangle, okay? Now I should also say this is sometimes presented the other way up. You might not be surprised to see that it would equally work that way up. Okay? And if the angles and the sides were labelled P, Q, R, you could rewrite this as P over sine capital P equals small q over sine capital Q equals small r over sine capital R. Okay, it's quite a nice rule, to be honest. So there it is. Now then, let's see how we use it to answer some maths questions. Alright, let's just put a rule down here. Okay, and now I'm going to make up a question. Okay, now we're just going to do one half of the sine rule today. We're going to look at finding sides. Alright, so I'm going to put 8 centimeters here. I'm going to give you this angle here of 32 degrees, and then I'm going to give us this angle here, which looks like it's something like 120 degrees. And what we're going to do is calculate this side, which I'm going to call little x. Okay? Now then, we're going to be able to use the sine rule because we have a side and opposite angle pair. Okay, I'm going to write that down because that's important. We have a side and opposite angle pair. You cannot use the sine rule unless you have those two things. Okay, but we've got it here, 8 centimeters. The angle opposite to 8 is 32. Okay, I wouldn't say 120 is opposite 8. I'd say that angle there is next to 8 because this line here helps form the 120 degree angle, and equally this line here helps form this angle, whereas this angle is formed by these two lines. So that's what we mean when we say opposite. Okay? Right, so we're going to use this. Now the thing about this that not a lot of people understand the first time they see it is we're just going to use a bit of it. So I'm going to cover up this section with my ruler, and we're just going to use these two things being equal to each other. We're not going to use all three. We don't need to. We're just going to use 2 of them. And you generally only ever use 2 of them. Okay? Now these sides aren't labelled. I don't really need them labelled if I remember that it's side and opposite angle. Side and opposite angle. So, I'm going to think of A as X. So we're going to have X over sine of the opposite angle to X, which is 120. And that will equal, this needs to be a side, because that's a side, so it's 8, over sine of the opposite angle, which is 32. Now, if that worries you and you don't like that, you can just start relabeling everything. You can kind of think of this as side A, this is angle A, this is side angle B, sorry, so therefore this is side B, and then this is angle C, and this is side C. But you'll notice we're not really worried about C. We don't know this length, and we're not asked to work it out, and we don't know this angle, and we're not asked to work it out. This is why we're ignoring this part of the rule. Anyway, we get to an equation now, and there's only one unknown in this equation. It's X. Okay. Now remember that this is just a number that you could get off of your calculator. So if you think of that as just one number, how do we get that number there over to the other side of the equation? Well, at the moment it's being divided. So if you want to put it on the other side, you want to do the inverse of dividing, which is multiplying. So this is what I would write. There it is there, and then you're just going to get your calculator and type it in. It's nice and easy like that. So here we go. I'm going to use the fraction button this time. 8 over sine 32 times sine of 120. And we get 13.07. I'm going to round that to 1 decimal place. 13.1 centimeters is the length X. Okay? So that is how you go about using the sine rule to work out an angle. Alright? I'm going to stop this video so it's nice and brief, because you might be answering some questions.